The sixth topic is similar to the fifth topic. Here also we need to sketch the graph using the first and the second derivative properties. There are many methods to do it. We will use the first and second derivative property, and then just like the previous video, we will directly solve graphing in calculator. Now over here, first is always the finding the derivative. Find the first derivative, that is f dash of x, and whatever the answer you get over here must be equated to 0 to solve for critical numbers. Now over here, when you solve, you get the critical numbers as 0 and minus 3. If you are getting confused with this, all you can do is put it in the calculator and you can get it mod 5 and 4 for cubic. So type the values. What is the coefficient of x cube? 4 of x square is 12, then it's 0 and 0, and now you'll get minus 3 and 0. So this is the critical numbers. Now after the critical numbers are there, you can draw the diagram for the increasing and decreasing parts. So this is studying the first derivative. You've done the derivative. Take the critical numbers in ascending order. Minus 3 is first, then 0, and take any test value less than minus 3. So I can take minus 4 or minus 5 or minus 10, anything, it's fine. You will get the same answer. You need to take this test value and put it in the f dash of x. Instead of x, put minus 4 and solve. And then from minus 3 to 0, say for example 1. Take this and put it over here. And lastly, from 0, sorry, I have made a mistake over here. It's minus 1 over here, put it over here. From minus 3 to 0, it's minus 1. And lastly, you can take 1. The reason why I'm taking simple values is it's easy for you to calculate. If I take 1, I know it'll be 4 plus 12. So it'll be again plus over here. Otherwise, if you take say 10 or 20, it's going to be, it'll take time for you to calculate. Take simpler values, it's easier. Now, after this, you will come to know over here it's decreasing and then over here it's increasing. Both the points. So we know increasing function is from minus 3 to 0 and from 0 to infinity, whereas it's decreasing from minus infinity to minus 3. And what next? We need to find the second derivative. Before there, this graph is something like this and it goes up. So we have a local minimum at minus 3. So this is the value. Now next one is second derivative. Find the second derivative and then you can find the concave up and down. But after finding the second, doing the double derivative, you need to equate this to 0. I'm sorry, I just realized this. This is double dash over here. Okay, this must be equated to 0. How do you find this? We have first derived it, right? F of x was derived, we got this. Now derive this again. 3 times 4 is 12x squared. 2 times 12 is 24x. And then you can put this in calculator. I'll show you over here. Now it's mod 5 and 3 because it's quadratic. Power 2 is maximum. It's 12, 24, 0. The answer is minus 2 and 0. Now over here, again you can solve the same thing. Similar, just like what we had done studying the first derivative, we can study the second derivative. Now over here, you must take the values from the second derivative. Okay, these are the inflection points. Now take any test value less than minus 2, sorry, over here. It can be minus 3. Over here you can take as minus 1 and 1. Now don't put in f dash, you need to put these in the f double dash or the second derivative values over here. This value, so minus 3 will be over here, 12 times minus 3 whole square. That's 24 into minus 3. That's how we do it. Now once you solve it up, you will get over here plus, minus, plus. So what happens is, wherever it's plus, it opens upwards. Wherever it's minus, it opens downwards. And wherever plus, again, it opens upwards. So it's concave up, down, and up. See, if it was just so much information, we just know it's something like this. But now we have more information. Now we know it's concaving upwards and then downwards and then again upwards, something like this. You know, we know the graph is going down, up and up, but we know it is upwards till over here, till minus 2, and then it is downwards till 0, and then again it is upwards. So we get a better understanding of the graph. This is very, very useful for that. And this is concaving upward, the regions. Now over here we have inflection points. Inflection points are the points when we equate the second derivative to 0, we get the inflection points. Now then graphing, we can find the end behavior. Just put the x value, huge x values, and solve it up. You can get it. Or there are many different methods to do it. Now they have used long methods to solve the y-intercept and y-intercept of the graphs. Now over here, this is the final graph. Now I want to quickly make a point. We had concave up, down, up, and we had only decreasing, increasing, increasing. This is very, very crucial information because you have to finally draw the graph. So you will have four graphs. How easily by first and second derivative you can find out is from the shape. This tells us till -2 it is concaving upwards over here, and -3 was the minimum point. We got it in the first derivative. -3, you can check it back, and this -2 it was upwards. Then it is increasing. Yes, it's going up, but look over here. It is concaving downwards until 0, and then from 0 the inflection point where concave changes goes upwards. So the inflection points are very important. We had got -2 and 0. These are the points where concaving upwards or downward changes. See, we had at -2 and at 0. So you can see over here at -2 it's upwards, and then it's downward, upward. So this is the thing. Otherwise, we had seen in the previous video just directly to use calculator. All you need to do is over here in your calculator, type this out. For example, take any value, say -2.5. Instead of x, put the -2.5 value. -2.5, the whole power 4 plus 4 into, now again, -2.5 cube minus 1. Now the answer is -24.43. Let's see at -2.5. Yes, it's about 24.43. Similarly, take any point and check the answers. Now you will have the four graphs because this is topic number 6. You will have MCQs and you will have the graph. So just you will be given with the equation and you will have four graphs. So trial and error with all the four graphs and you can find the answer. If not, you can just use this first derivative and second derivative. It is very, very straightforward. You can understand the the characteristics of graph and find the graph. Or whichever method which you're comfortable with, you can follow that method.